Welcome back. Tonight we're talking about rational functions day 2. So we'll do a little bit more with asymptotes, and then we will talk about solving equations with fractions in them. This will be a review for those of you who had Honors Algebra 2 last year. It'll be new though for those people who didn't. So do your best, do the best that you possibly can. So rational functions day 2. The only type of asymptotes that we didn't talk about are oblique asymptotes. Oblique asymptotes happen when the top degree is bigger than the bottom degree. So if A degree is bigger than B degree, then that tells us we're going to have an asymptote. We would have the asymptote in the equation that you get when it's y equals only when you have the number that is the quotient. You sort of ignore the remainder. The remainder doesn't matter to us. The only thing that matters is what you get on top of the divising bar. So it's y equals that. And that will be what our asymptote will be. And that's kind of what that says there. Yep, and that's all that it says there. So here's our equation. We have the equation f of x equals x squared plus x minus 8 over x plus 3. So we're going to look to see if we have all the other stuff that we did before. So we would start by finding our domain. Well, our domain will be all of the reals except for when x equals -3, because that's when the denominator would be undefined. Then I'm going to look and see if there's going to be a vertical asymptote. Well, yes, there will be. The vertical asymptote will be when x equals -3. And then I will look and see, will there be a horizontal asymptote? Well, in order for it to have a horizontal asymptote, I would either have to have the top smaller than the bottom, or the top equal to the bottom. Well, that doesn't happen in either case, so there's no horizontal asymptote. But now I look and notice that the top is bigger than the bottom. Since the top is bigger than the bottom, that tells me I will have an oblique asymptote. So that's everything that I just said for that. Again, copy down the problem because I didn't include that on the next page, so make sure you have that copied down. So as I said, since the degree on the top, okay, look at that, I did copy it down. Sorry about that. So since I have the top bigger than the bottom, I'm going to do long division. When I do long division, I'm going to see that I get x minus 2, I get x minus 2 as my answer that I have here. The other part with the remainder, I really don't care about, so that doesn't matter to us. The only thing that I care about is the x minus 2. So that means my oblique asymptote will be the equation y equals x minus 2. Now, I'm going on the assumption that you're capable of doing long division, and that's one of the reasons why we had to learn long division. Synthetic division doesn't work quite as well for this. It somewhat does. You would just sort of ignore the last number when you do synthetic division, the last column. But really, it's easier if you do long division with this. So then we end up with y equals x minus 2. So then we would have to continue with doing what we had done before, which means we're going to have to find our x-intercepts and our y-intercepts. Well, we would find our y-intercepts by putting a 0 in for x. So if I put a 0 in for x, I would have -8/3 as my y-intercept. So that's 0, -8/3. And then I would have to find my x-intercepts. My x-intercepts I get, just like I did before, by setting the numerator equal to 0. Well, unfortunately, that doesn't factor. So you're going to have to use quadratic formula to find the two intercepts. Since we're graphing, it's okay to use the quadratic formula and the approximation of the square root of the number that you get. So here are the answers to the quadratic formula and the other asymptotes, which is there. I'm going to get my asymptotes, the two different ones from quadratic formula, -1 plus the square root of 3 over 2 and -1 minus the square root of 33 over 2, which will be approximately 2.37 and -3.37. And then you're going to graph the two of them as well as the y-intercept and the asymptotes of the vertical asymptote at -3 and the slant asymptote at y equals x minus 2. Then you're going to start putting numbers into the equation. So I would be able to solve that. And let me show you the graph to make sure that we all understand where we're putting points into the intervals. So once I've graphed it, and again, all I've done so far is I've graphed my vertical asymptote, I've graphed my slant asymptote, which is the dotted line there, and I've graphed my intercepts. So I have an intercept that's here, here, and here. From there, I need to put in points into my graph to get the rest of my equation. So you're going to want to put something into the graph over in this sort of section in here. So that's one part of the graph. I need to put some values that are in here to figure out, does the graph go up here or does the graph go down here? So I'm going to put some x values in between like -1 and +1 to figure out, is it going to go down to the bottom or is it going to go up? As you can see, obviously, it's going to go down to the bottom here, and it's not going to be up here in the first and second quadrants. And then you also want to put something in over here to see whether the graph is going to be going up or going down. So once you've substituted those values in, and you probably want to do a couple. You probably want to do a couple over in the interval that's smaller than -4, and you want to do something that's in the interval that's bigger than -3. So something that's over in this section, a couple of points, just to see what it looks like, so you can get the general gist of what the equation is going on. And then there's your graph. So here's another problem, same basic idea. Oops, wrong way. So here's my graph. And there we go, sorry about that. And my equation this time is x squared minus 9 over x squared minus x minus 6. Well, in order to solve the equation and to simplify it and to find the asymptotes, I'm going to need to factor. So once I factor, I can factor the top into x plus 3 and x minus 3, and the bottom factors into x plus 2 and x minus 3. Notice that the x minus 3's cancel out. So I'm left with only one place where I'm going to have a discontinuity. My discontinuity is going to occur at -2. But I also know that I'm going to have holes in my graph this time. So when I talk first about, the first thing we're always going to talk about is the domain. So the domain would be all the reals except +3 and -2. Although you can cancel it out, you still can't have those particular numbers be part of your graph. So that means you are not going to have them in your domain. So it's everything but -2 and +3. And that's what that says here. Then I'm going to figure out my vertical asymptotes. Since I am able to cancel out the x minus 3's there, I won't have a vertical asymptote at x equals 3. I'll only have a vertical asymptote at -2. So I will have a vertical asymptote at -2. Then I will look and see, and as I always say, it's always easier to go back to the original, which I can't quite get up there for some reason. There we go. If I look at my x squared over x squared, that tells me my coefficient is going to be 1. So that means my horizontal asymptote is going to be y equals 1. Then the next thing I need to do is I need to see if I'm going to have an oblique asymptote. Well, if I look at the top and look at the bottom, I can see that the top and the top is not bigger than the bottom. So that means there is no oblique asymptote. So the only asymptotes I have are x equals -2 and y equals +1. Then I would need to find my y-intercepts. My y-intercepts would happen at +9/6, which is 1.5. And my x-intercepts I would have at +3 and -3. But again, since I can cancel out that +3, that means the only asymptote, the only x-intercept that I'm going to have is at -3. And if I look, let's see, I think that says that here. Oh, nope, it's actually on the next page. There it is. There's my asymptotes and my answers there. There are my intercepts. Now, the only other thing that we haven't talked about before is we have that discontinuity that we can get rid of, a removable discontinuity. And the removable discontinuity is at 3. So remember in the domain we said that we weren't allowed to have a 3 in our domain. But if I look at the simplified equation where I have x plus 3 over x plus 2, I can have a 3 in that. So what will happen is there will be a hole in the graph, a literal, well, not a literal hole, but a circle, open circle, at the point 3/6. The reason why I have 6/5 is if I put 3 into the equation, 3 plus 3 is 6, and 3 plus 2 is 5. So that means there will be a hole at the point 3, 6, 5, because the original function was undefined. And if I look, I think it says that. Yep, look at that, it says the same thing. From there, in order to graph it, I would need to graph my asymptotes, I would need to graph my intercepts, and then I would make a table, and I would plug different points into the different parts of the graph to find out what's going to happen. And once I've done all of that, that's what the graph should look like. It does look like a hyperbola. That should be pretty easy. That's all we're going to be doing with graphs of rational functions. Now we're going to sort of switch into solving equations. So there's a couple of different ways that you could do solving equations. So let's look at the first one. The first one would be x minus 4 over x minus 6 equals 0. One choice you could do is you could move the 4 over x minus 6 to the other side and make that x over 1 and cross multiply and solve. Looking at that now, that's probably the easier way to do it, but of course that's not the way that I did it here. What I would do instead is you can multiply the entire problem, which means each term, which remember x is a term and the 4 over x minus 6 is a term and the 0 is a term. You're going to multiply each term by the common denominator, and remember that's over 1. So the common denominator is x minus 6. So if I'm going to multiply each term by x minus 6, notice the red, I would have x times x minus 6 times 4 over x minus 6 times x minus 6 equals 0 times x minus 6. When I do that, I'm going to be left with this x minus 6 canceling out with this x minus 6. And this is going to cancel out because that's just 0. So I'm left with x squared, and I get that by distributing, minus 6x minus 4 equals 0. So I'm still solving that equation. So in order to solve the equation, I'm going to solve it. Unfortunately, it doesn't factor, so I have to use the quadratic formula. And if I use the quadratic formula, I'm left with that answer of 3 plus or minus the square root of 13. So in this particular case, all we did was we took the function and we multiplied each term by the common denominator. Now I'm allowed to do that because it is an equation. I can only multiply by each term by the common denominator if it's an equation. If it's something where I'm just simplifying, then I actually have to find a common denominator and go from there. But if I were simplifying, I wouldn't be solving, so it would be a little bit of a different problem. So here's another equation. I have x plus x over x minus 1 equals 3x minus 2 over x minus 1. So our common denominator is x minus 1. Because again, remember, this is over 1. So I'm going to multiply each term by x minus 1. So I have x times x minus 1 plus x over x minus 1 times x minus 1 equals 3x minus 2 over x minus 1 times x minus 1. And here's my favorite part. Then you get to cancel out. I can cancel out here and here. I can cancel out here and here. So I'm left with, and again, I'm distributing x squared plus x, x squared minus x plus x equals 3x minus 2. Of course, in order to solve the equation, it has to be equal to 0. And lucky for us this time, this one does factor. Oops, apparently on the next slide. Or not. Wonder where it went. Well, anyways, if it does factor into x minus 2 times x minus 1, and that's going to equal 0. And then I would solve the equation, and x equals 2, and x equals 1. But then I really need to go back and double check and make sure that all of those answers that I get really do work. So if I substitute the 2 back into the original equation, I would be okay, because I would have 2 plus 2 over 1, so 2 plus 1, so that's 3, equals 6 minus 2, which is 4, over 2 minus 1, which is 1. Actually, that should be 2 plus 2. So 4 equals 4. So that's all right. Okay. But then if I put the 1 in, because remember we had 2 solutions, the other solution was 1. If I put the 1 into the solution, if I put the 1 into the solution, I'm going to get something that's undefined in the denominator. So I can't have that, of course not. So instead what I'm going to do is I'm going to cross that out. That's not a possible solution. So the only solution that I can have in this particular instance is 2, because if I were to use the 1 in the equation, it would not exist. So that's basically what we're going to be doing with solving equations. I will do some more, of course, the next time I see you in class. And of course, we'll graph some more rational functions in class tomorrow as well. Hope you have a great night, and I'll see you next time. Good night.